here today. All right. So now that we have our PVC, we're going to turn our paper. And I'm going to label these places. So the digit 1 is in the ones place. The digit 2 is in the tenths place. The digit 5 is in the hundredths place. And the digit 8 is in the thousandths place. And if you remember from yesterday, we talked briefly about Tudor hates thunder. Give me a thumbs up if you remember that little story. Excellent. So if you're shouting out, I'm going to invite you not to do that anymore. Now what we're going to do is we're going to go over here and we're actually going to shade in the model just kind of like what you have on your blue tray. So when I go to the ones, place, I notice that I have the digit 1 there. So I'm actually going to outline this. I had a blue crayon here. I don't know what happened to it. I guess I'll just shade in this direction. All right, that represents the whole number 1. So we had 1 as in our ones place. We have 1 flat. Then we're going to move over to the tenths. We have the digit 2. So I'm going to go over and I'm going to shade in 2 tenths. I'm going to go over to the hundredths, and I notice that I have the digit 5, so I need to shade in the corresponding amount. So we have 5 here. And then in the last area, we have the thousandths. So I notice that I have an 8 in the thousandths, and because it's so super tiny, I'm going to zoom in. Each one of these little boxes, right here has 10 in it. And I only need 8. So I'm going to leave 2 unshaded. Now I'm going to zoom back out just like that. Okay? So this is basically the number that we have on our blue tray. Expanded form. We have 2 ways that we want to write this. We have the fraction way and we have the decimal way. So when we start with our whole number, we start with the number 1. And the number 1 is just the number 1. There's no other way to decompose that. But when I think about the tenths, if I'll just relate that to this simple thing, anytime we want to write fractions, we always want to think about part over total. And if you'll use that to help you build a fraction, it'll never be hard. So when I look at this total picture here, I see that I have 10 total pieces. So 10 is my denominator. And how many pieces of the 10 did we shade, Tucker? 2. So 2 becomes my numerator. When I look at this individual model, how many total pieces are in this model? Akarsha. 100. So 100 is my denominator. And when I look at this individual model, how many pieces did we shade? Carrington. 5. And this last model, how many equal pieces are in this last model, Brian? How many equal pieces are in this last model? 1,000. So that's my denominator. And we have shaded in 8. And if I put my action sign between them, then I have just created my expanded form and fraction form here. Now all fractions have equivalents. So we have to write the decimal value as well. So the number 1, again, just stays the number 1. But if I want to relate it to a decimal, I'm going to go back to my PVC, and this is what I know. I have 0 ones in this picture, but I have 2 tenths. If I go back to this picture, I have 0 ones, I have 0 tenths, but I have 5 hundredths. And if I go to this third picture, I have 0 ones, I have 0 tenths, 0 hundredths, but I have 8 thousandths. And then again, I can just put in my addition symbol. There is my expanded form and decimal form. Expanded notation is just a more, let's see, it's just another way to decompose the number, but now that we are familiar with parentheses, we're going to use those parentheses. And actually, if you used your processes of GMA, you would be able to figure out what the number is if you wanted to solve it that way. So when we go to expanded form, again, we're going to start with our whole number. Our whole number is 1. And this time, I'm going to go to my picture, and I know that I have the value 2. And I know that I have a picture that's representing the tenths. So the 2 has a value of tenths. And we're writing this as a fraction, so we would say times 1 tenth. And anything times 1 is going to give me 2 itself. 2 times 1 is 2, right? So if I say 2 times 1 tenth, I'm going to get 2 tenths. And now I'm going to put parentheses around that. I'm going to move over to the hundredths place. I have the value 5, and we're going to multiply that by the value of the model, and that is 1/100th. And then we're going to put parentheses around that. And now we're going to our last model, which happens to be 8. And we're going to multiply that by the value of the model. The model is 1,000. And we put parentheses around that. The action signs that are needed between the parentheses are just addition. And actually, we can say 1 times 1 here. Because we wanted to break that down by the ones place, right? Yep. So if we go to our decimal form, that's 1 times 1, which would give you 1, plus the value again is 2, but this time we need to put the decimal form, which is 0 ones and 1 tenth. There is a number that is shaded in the tenths place. We're going to go to our next one. We have the value 5. But our model is representing hundredths, so we would multiply that by the hundredths place. So we have 0 ones, 0 tenths, but this model is showing the hundredths place. And finally, we have the number 8, and this model is being represented by a decimal that is representing the thousandths. So we have 0 ones, 0 tenths, 0 hundredths, and the thousandths is represented here. We would put this together by using the addition symbols. Now that we've decomposed this all the way, we're going to put it all back together. We're going to write the word form. We're going to layer up our model. And then we're going to talk about how the decimal and the fraction are equivalent. What does the word equivalent mean? It means equal. So if I steal my decimal from here at the top, I would just write 1 and 258 thousandths, just like that. But my fraction would look like a whole number 1 getting to stand all by itself, and the parts would be 258 out of 1,000. So now what we're going to do is we're going to shift. I'm going to actually do the model next. So if we go to our fraction, we have the whole that needs to be represented just like we started with. We're putting this all back together. So I'm going to shade in my whole that represents the number 1. Your side talking is very distracting. It's making me not be a very good teacher right now. I wish that you would stop. There's my whole. And now, this is the tricky but easy part. Do you see this model that is represented down here?
Yes.
It is a thousandths model. And this is where a lot of boys and girls get confused. But we're going to take what we know from up here, the decomposing, and we're going to layer it down here together. So, we know that we had 2/10. So I'm going to go to my model and I'm going to outline 2/10. Okay. How many hundredths did we have? Lexi? 5. So I now have 1, 2, 3, 4, 5. I'm going to shade in those 5. And in the thousandths, we had 8. So this is where we're going to have to be super careful, and we're going to only shade in 8. 2, 4, 6, 8. Leaving that tiny little sliver there, unshaded. So this is now layered on top of each other. The last thing that we have to do is to write our word form, and we kind of already talked about this. What is the number that's being represented in the ones place? Avery. 1. Good. And instead of decimal or point, what would we write? And. And then we're going to chunk these 3 numbers together. Everybody say 258.
258.
So we're going to have to write that out. So we would write 258. And this number's last name, the last digit is in the thousandths. So what is the last name of this number? Asan. Thousandths. Just like that. Hello.
Is this your home?
No, they're with McGee right now. All right. Are there any questions over that?